Question 6. The speed of a car as a function of time is shown in figure 3e1. Find the distance traveled by the car in 8 seconds and its acceleration. Solution. From the given figure, the velocity changes from 0 to 20 meters per second in the interval of 8 seconds. So, the average acceleration is calculated as the change in velocity divided by the change in time, which is 20 meters per second / 8s equals 2.5 meters per square second. The distance traveled by the car, s, can be found using the equation of motion. S equals ut plus 0.5 at superscript 2, where u is the initial velocity, a is the acceleration, and t is the time. In this case, the initial velocity u is 0. Substituting the known values into the equation gives s equals 0 plus 0.5 by 2.5 meters per square second asterisk 8s superscript 2 equals 80 m. So, the car travels 80 m in 8 seconds with an average acceleration of 2.5 meters per square second. Note that this analysis assumes the car's acceleration is constant over the 8-second interval. If the car's acceleration changes over time, a more complex analysis would be needed. Question 7. The acceleration of a cart started at t equals 0 varies with time as shown in figure 3e2. Find the distance traveled in 30 seconds and draw the position time graph. Solution. Let u equals initial velocity and v equals final velocity. In the first 10s, the distance traveled, s1 equals ut plus 0.5 at superscript 2 equals 0 plus 0.5 asterisk 5 asterisk 10 superscript 2 feet equals 250 feet at 10 seconds. V equals u plus at equals 0 plus 5 times 10 is equal to 50 feet / section. Therefore, the distance traveled from 10s to 20s, it moves with a uniform velocity of 50 feet per second. Again, the distance covered from t equals 10 sec to t equals 20 sec, s2 equals vt is equal to 50 times 10 equals 500 feet. From the figure, the acceleration is constant between 20s and 30s, i.e., minus 5 feet / m superscript 2. At 20s, the velocity is 50 feet per second, and the time, t equals 30s, 20s equals 10s. S3 equals ut plus 0.5 at superscript 2 is equal to 50 times 10 plus 0.5 asterisk minus 5 asterisk 10 superscript 2 equals 250 feet. The total distance traveled in 30s equals s1 plus s2 plus s3 equals 250 plus 500 plus 250 is equal to 1,000 feet. The position time graph is not provided in the text, but it would typically be a plot with time on the x-axis and position on the y-axis, showing how the position of the cart changes over time. The shape of the graph would depend on the specific acceleration function given in the problem. Please. Question 8. Figure 3e3 shows the graph of velocity versus time for a particle going along the x-axis. Find A, the acceleration, B, the distance traveled in 0 to 10s, and C, the displacement in 0 to 10s. Solution. The initial velocity, u, is 2 meters per second. The final velocity, v, is 8 meters per second, and the time, t, is 10 seconds. A, acceleration. Using the formula v equals u plus at, we can solve for acceleration, A, as follows. A equals v u / t equals 8 meters per second to 2 meters per second / 10 seconds equals 0.6 meters per square second. B, distance traveled. We know the relation v superscript 2, u superscript 2 equals 2 as, where s is the distance traveled. Solving for s, we get s equals v superscript 2, u superscript 2, / 2a equals 8 meters per second, superscript 2, 2 meters per second, superscript 2 / 2 by 0.6 meters per square second, equals 50 m. C, displacement. In this case, the displacement is the same as the distance traveled, i.e., 50 m. This is because the particle is moving along the x-axis in one direction, so there is no difference between the total path length, distance, and the straight line distance from start to end. Question 9. Figure 3e4 shows the graph of the x-coordinate of a particle going along the x-axis as a function of time. Find A. The average velocity during 0 to 10s. B. Instantaneous velocity at 2, 5, 8, and 12s. Solution. A. The displacement from t equals 0s to t equals 10s is 100 m. The average velocity is calculated as the displacement divided by the time, which is 100 m/10s equals 10 meters per second. B. The slope of the xt graph gives the velocity. At different times, the instantaneous velocity is as follows. At t equals 2s, the instantaneous velocity is 20 meters per second. At t equals 5s, the instantaneous velocity is 0 meters per second. The particle is at rest. At t equals 8s, the instantaneous velocity is 20 meters per second. At t equals 12s, the instantaneous velocity is minus 20 meters per second. The velocity is negative as the particle moves towards the initial position. Please note that this analysis assumes the particle's velocity changes continuously over time. The instantaneous velocity at a given time is the slope of the tangent line to the xt graph at that time. If the particle's motion is not smooth or if the xt graph is not differentiable at a given time, a more complex analysis would be needed. Question 10. From the velocity, time plot shown in figure 3e5, find the distance traveled by the particle during the first 40 seconds. Also find the average velocity during this period. Solution. The area under the velocity time graph gives the distance traveled. The distance in the first 40 seconds is equal to the area of triangle OAB plus the area of triangle BCD. This is calculated as follows. 1/2 by 5 by 20 for triangle OAB plus 1/2 by 5 by 20 for triangle BCD equals 100 m. So, the distance traveled by the particle during the first 40 seconds is 100 m. The displacement is 0 as the average velocity is 0. This means that the particle returns to its starting position after 40 seconds. The average velocity is calculated as the displacement divided by the time. Since the displacement is 0, the average velocity is also 0.